Okay, so we're going to integrate, but remember that there are no integration rules there's not a product rule for integration. There's not a quotient rule for integration. So instead, we are going to, it says when we differentiate composite functions, we use the chain rule. So there's a reverse process called u-Substitution, kind of undoing the chain rule. So let's talk about just in general what that looks like. There's not really a spot for it, so we're going to do this here. So if I'm going to integrate f of g of x times g prime of x dx. Okay? So do you recognize this as like we took the derivative of something using the chain rule? So that would have been the derivative of big F g of x. So that makes the derivative times the inside, and then we take the derivative of the inside, right? So we are going to, you pick something for your u. And sometimes it's really obvious. Sometimes you're going to pick the wrong u first, and then you decide, oh, that doesn't make sense, so we're going to redo it. So what we're looking for in general is the inside part of the function, right? The inside function, that g of x. So I'm going to say u is equal to g of x. Okay? And then I'm going to take the derivative. So the derivative of this, that's derivative of u, equals g prime of x dx. Okay? Now we're going to pause here for a second because I want to talk about this notation. Right? So if I have, let's just say y equals 3x squared. Okay? Just y equals 3x squared. So one of the things that we saw when we weren't using f of x, we would say that, okay, so then dy dx, remember writing things like that, equals 6x. Make sense? So this is still, this doesn't always have to be connected together. If I wanted to get dy by itself, I can multiply both sides by dx, so I get dy equals 6x dx. Does that part make sense to you? You see how we get from one to the other? Like, this is just how we've been taking derivatives. But what I want you to see is we wrote it like this a lot because we wanted to know what dy dx was because we were looking for that rate of change. Here, we're going to want like dy, but it's really du. Have that isolated. So we're going to kind of skip this step. Instead of y, that becomes dy, right? And then this is 6x, then we have that dx there. You with me on that? So that's why I can go from here to here, because the notation looks a little bit different. But you with me on that? It's going to make it a lot easier than writing it the other way. Okay? I will also tell you that Ackerman and I had a conversation today, and he actually teaches this a little bit differently, so then that made me question everything. I was like, great, that's not the way I was going to teach it. But then he told me he's like the only one in the district that teaches it that way, so I was like, okay, I felt better. And really it's kind of a one or the other, and he said you should teach whichever one makes the most sense to you. This way makes the most sense to me. And the only reason I'm even saying anything is that I know you have friends that are probably in his class, and if you're working together, your work's going to look a little bit different. But overall, after really thinking about it, this is the way Ms. Bruce does it too, and I really think that this way in general makes a little bit more sense when you're learning it. I understand why he does it, and there's nothing wrong with it. It's just different. Okay, so just want to throw that out there in case I don't want you to get confused by working with somebody. Okay, so if we know this then, so I took g of x, and I'm going to say that's u, right? So I get this, and then du is g prime of x dx. So now I'm going to substitute. I'm going to have the integral of, so u is g of x, sorry. So then that's going to be f of u, and then g prime of x dx is du. Do you see what I substituted there? G of x got replaced with u because u equals g of x. When I took that derivative and I got g prime of x dx, I replaced this with du. So now I would integrate this. Okay? You see how that works for the substitution? So that's just the general form. The general form always looks weirder and is a little bit more confusing than it's actually doing it. I think it's important for you to see that process as well. All right, so let's do one of these. So you have to decide where your inside function is. I mean, technically this is kind of an inside function, but really this function to the 5th power, so it's a function inside of a function. This is going to be my inside part. I'm going to choose that for u. Okay? So I'm going to say, all right, well, u is equal to x squared plus 1. Then I'm going to take the derivative, so du equals 2x dx. Everybody with me? So now I'm going to rewrite this as the integral. Instead of x squared plus 1 right here, I'm going to put u. So that gives me u to the 5th. And instead of 2x dx, I'm going to get what? Du. Okay. But then we have to integrate, right? I kind of stopped over there because it didn't make a lot of sense to do anything else. But now I'm just using my power rule, right? So this is going to be equal to u to the 6th divided by 6 plus c. See how much more simplified that was? And this is what we're taking the integral, and this is what we're integrating here. So now that I have that, it's out of the integral. And remember, the integral symbol and the du, these are operators. It's kind of like after you take the square root of 25 is 5. It's not the square root of 5, right? The square root sign goes away after you do it. After you actually integrate, use the integral rules, the integral sign and the du are gone, okay? So now I put this back in. I'm going to write this as 1/6 just because I think it makes it look a little bit better. So 1/6 times, and instead of u, this is u, it's x squared plus 1 to the 6th power plus c. Okay? Ask me a question. Let me know if I lost you somewhere. What's your question, Kylie? Where did I lose you? Yeah, I just changed because I could have written this as 1/6 times u to the 6th. And really, you're going to probably see it more like this than over 6. But yeah, it's the same thing. And it's correct either way. You know, it's one of those things that it's not wrong either way. I feel like this is probably the way you would see it if it was written for you, like in a multiple choice or something. Okay. What questions you got? Okay, so there's a couple of basic rules here that can kind of help you with making sure that you're doing it right. And we'll put these here too because we have some room. First thing is make sure you eliminate all x's from the question. Okay, so notice we only had u's left. There was no x's. If there was still an x in here somewhere, we either did something wrong or we chose the wrong u or we didn't finish or something like that. Then number 2, you make sure you have one of the 9 antiderivatives we know, which is what's on the front of yesterday's assignment. Okay, there's 9 of them there. Again, the great majority of them are trig, so hopefully we can get front and back with that. And then the E, which is easy. But it can't be anything else weird. Like if you don't know how to integrate what you're left with, then something isn't right somewhere. Okay? Everybody good so far? All right. So, and when you're looking for what am I going to use for u, because again, sometimes we might choose the wrong u, and that's okay at first. You usually look for something inside parentheses if your exponents have variables or something in the denominator. Okay? And in this case, there's no parentheses here, but it is the kind of the inside function, so it will kind of make the most sense for us to try that. So let's try that. So this is my inside part. I'm going to say u equals x squared plus 3. Okay. So I'm going to take the derivative, so du equals 2x dx. Now, on this first one, when we got 2x dx, I had a 2x dx right there. Do I have a 2x dx in here? No. What do I have that's kind of close? X dx, right? I mean, it's not next to it, but still it can be multiplied by it, right? X dx. But in order for me to replace that, I need it to be 2x dx. So if I rewrite this as the integral of 2x, the square root of x squared plus 3 dx, that gives me my 2x dx, but I've changed the value. So in order for me to have a value that's not changed, I need to multiply by a 1/2 on the outside. because 1/2 times 2 is just 1, right? We can factor that out. So if I'm going to multiply by 2 on the inside to make it match, I have to multiply by 1/2 on the outside for it to cancel out. You with me on that? So basically I added it, put a 2 in here to multiply by that, but then I have to multiply by 1/2, so when I factor that back in, it looks the same. Ask me a question, Adrita, because I can tell you don't get it. Oh, the inside of this? Oh, yeah. Yeah. What's your question? Okay, I will ignore you. All right, so now we have this 2x dx, that's our du, right? And then this is our u. So I'm going to have 1/2 times the integral of, instead of the square root of u, are you okay with me going ahead and writing u to the 1/2 power? Never mind, I'm going to write square root of u. Tell my little looks on your faces. I'm substituting u in here, and then this becomes du. Okay, everybody with me at this point? Am I still ignoring you? Oh, it's fine. I started to do it, like the first time I worked through this, I wrote it that way. And then I decided kind of that might be, but it's fine. There's not a problem with that at all. So you're saying like put it last so it's actually next to it. That's absolutely fine. Or you could kind of go, okay, this is what's together. Like whatever works for you, it's fine. It looks like I told hello. But yes, if you wanted to, that's fine. And because we're going to start writing less and less, but you don't have to. I'm going to kind of show you why we wouldn't have to necessarily rewrite the whole thing. Again, first time for sure, I want to rewrite the whole thing so you understand what's happening. And then, maybe on this next one, we don't need to do that. But yes, that totally works. Okay. All right, so everybody's with me on here, right? Okay, so now I'm going to rewrite this again, 1/2 the integral of u to the 1/2 power du. Because I really need it like that in order for me to integrate. That's why I was asking you if you were okay with me writing it right here, but I could tell by the looks on your faces the answer was no. And I don't want to lose you because of the u stuff. But eventually I think you might be okay. If you need to write it, that's fine, whatever. Okay, so now I'm going to actually integrate. I still have this 1/2 on the outside, right? Then I add 1 to the exponent. So what does my exponent become? 3/2. And then I divide by 3/2, which is the same as multiplying by 2/3, right? And then I have plus c. Everybody with me? So Lolly asked me a question. Okay. du doesn't become c. That's a good question. du and the integral symbol go away because we integrated, but because we're integrating and we're getting the general solution, that's why we do plus c. But basically, once you lose the du, you better have a plus c, if that's kind of what you're asking, yes. Doesn't technically replace it, but yes. But it does at the same time. Okay, I know. Yes. Another way for me to write this would be to be divided by 3/2, and then I would multiply by 2/3. It's because I'm dividing by a fraction, so I just multiplied by the reciprocal.
Would it be wrong if I use the variable?
99% yes, because it's literally called u-Substitution. It's not something that you can kind of use your own thing. That's a great question for Miss Bruce tomorrow. Why would you want to use your own variable? I'm just curious.
Because a lot of times I do understand. It's a bunch of like loops and stuff, so I always get confused and I mess up.
Okay, so the u's are confusing for you. Is that what you're asking? Okay, that's a great question. Hold on to that. I don't know the answer to that. I would think, honestly, okay, let's just think logically through this. I guess if this was W and you made sure that was W, you would probably be okay. But ask her that tomorrow, because that is a very good question, and I don't really know the 100% answer for that. I'm not sure. I'd probably be okay, but I don't want you to get confused for other reasons either. Okay, so now that we have this, everybody else, any other questions? Those were all good questions. Okay, so I'm going to cancel these out, so this is going to give me 1/3, right? So now I'm going to have 1/3, and then instead of u, I'm putting my u back in. That's x squared plus 3 to the 3/2 power plus c. What questions do you have? Okay. All right, so let's look at the next one. I know this is still pretty new, and I know that you may not be 100% comfortable with it, but what do you think we could use for u?
The bottom, the denominator,
What's under the square root? Yeah. Because we probably, I mean, at some point we may need to use a whole square root, but let's try with what's inside the square root, because that's more likely to be. Even though, yes, it's the denominator, so we go for that first, but I will go with what's inside there. So let's try that. So we're going to have u equals 3x squared plus 4. So du equals 6x dx. Okay, and remember, notation is very important, so you got to have the dx's in the right place, all that good kind of stuff. All right, so I need 6x dx. I only have x dx. So yes, so you can rewrite the whole thing if you want, or what I'm going to need to do is multiply by 6 in here, right? So what do I multiply by on the outside? 1/6. And then you can just kind of do that. And then when you rewrite it, it'll be there. Everybody understand why I did what I did? You sure? You could go straight to the 1/6, as long as you don't forget that 6, it's fine. Like I could have done it in the next step, but I want to make sure that it makes sense in there. Okay, we good? So I have the integral of 1/6, okay? This 6x dx is going to be my du, which I'm not going to put in the numerator, we'll put it out to the side. That makes sense, right? So then that gives me 1 over the square root of u and then du. What? All right, so now I want to change my roots to an exponent, so I'm going to have 1/6, the integral of u to what power? -1/2 du. Okay. So now that I have it in a power form that I like to be able to integrate, we're going to use our integral rules here. I still have that 1/6. I'm going to be able to use my power rule here. I add 1 to the exponent. What's -1/2 plus 1? 1/2. And I'm going to leave a little bit of space, right? And so I'm going to have u to the 1/2. Then I have to divide by 1/2, which is the same as multiplying by what? 2. I'll put my 2 over 1 just because I like it better that way. And then I cannot forget my plus c. Okay. So it is fine to put, u to the 1/2 over 1/2, but I would, me personally, I would only put it over that number if it's a whole number. Otherwise, I'd flip it and do the reciprocal with the fraction. Okay. And so then that 1/6 times 2 is going to be 1/3. And then this u to the 1/2, that's going to be a square root. I'm going to go ahead and put it back in a root. And that's going to be 3x squared plus 4 plus c. Totally fine. Square root of 3x squared plus 4 over 3, as long as it's clear that the square root is only in the numerator, you're totally fine. And then plus c on the outside, yes, 100%, that's totally fine. Okay. What questions we got? Okay. Let's do a trig one. What do we think we're going to use for u here? 3x. We're going to look for parentheses first. A cosine of 3x, I mean, if the whole thing is u, then does it really make any sense to make it u? I mean, you could. That is a possibility in some of them. But we're going to go with what's inside. Okay? So just stay with me here. We're going to go with what's inside these parentheses. We're going to make that our u. So u is equal to 3x. When I take the derivative, du is equal to 3 dx, right? In order for me to replace du, I need 3 dx. I only have dx. So I could multiply by 3 in here, which means 1/3 on the outside. Okay? So this gives me 1/3, the integral of cosine of u du. Everybody with me so far? So now I'm going to actually, I've gotten rid of all of my x's. That's the first thing that we had, our first rule. And then the second one has to be one of the 9. Well, this is a trig one. What do we take the derivative of to get cosine? Sine. So this is going to give me 1/3 sine of u plus c. Then I can substitute my u back in, and I get 1/3 sine of 3x plus c. Ask me a question. All right. I want you to try the next one. You got this. I know there's lots of problems on there because, and again, we may not do them all, but. So what we want, the reason you're multiplying it by 1/3, right, is because you want to multiply a 3 in here so that you can get 3x squared dx, right? So when you start replacing with the u, the 3x squared dx is what becomes du. So this isn't there anymore. Does that make sense? Okay. Yeah. Okay. So you can, okay, I was going to say you can't replace that du yet. Okay. Okay. So, no, I was talking now. I was just checking y'all's. So you're right about this being out here, but we need this to be 3x squared dx, right? So you're going to have to multiply a 3 in here, which means a 1/3 on the outside. So if you're going to do that, then you're going to have to rewrite 3x squared. Like you can't put any u's in there if you're going to leave the 3 in there. You with me on that? That's fine. That's fine. You just rewrite the whole thing. Like you can't have your u's and your x's mixed.
I feel like I'm missing something.
Plus c.
Okay, but
Yeah, but otherwise it's plus c. You're good. And again, not 100% sure this would be wrong, but the du always goes at the end because it's telling you like with respect to you, that sort of thing. So, but that's another one. You remember these questions. We're going to ask tomorrow to make sure. It's because it's technically the same thing, but you know. All right, so here's a couple of things that happened. And maybe me skipping this step was a bad idea. Okay, so y'all look up here real quick. It's fine to go from here to here. You cannot mix your x's and u's, all right? If you need to rewrite this whole thing instead of jumping to here, that is totally fine. But if you're going to start putting the u's, this 3x squared dx, that's what becomes du. So we don't put that back in here. We're here, okay? Then when we integrate, we're going to get 1/3. And when you integrate secant squared, you get tangent of u and then plus c, right? So that does give you 1/3 tangent of x cubed plus c. What questions you got? That's okay. Oh, and I was ignoring you on that other question. Did you figure out whatever your question was? You told me to ignore you?
Yes, I
Okay, good. All right, I want y'all to try this next one. I skipped that because I kind of crammed it in here. But yes, you need that. And that's why your 3x squared dx becomes du. Yes. And if it probably is helpful since it's new to you to rewrite it, and that's totally fine.
It's the same thing. Tell me which one you do.
No. Because this is a product. You can't do them separately unless it's addition. What do we use as what do we use as u? 5x. Okay, so if u equals 5x, then du equals 5 dx, right? So if we're going to have to multiply a 5 in here, we need a 1/5 out here. So 1/5 times the integral of sine cubed u cosine u du. So our first rule is to get rid of all the x's. Check. The next thing is we have to have something we can integrate that's one of our 9. Is there a product rule for integration? No. Is it possible to have 2 trig functions multiplied together and be able to integrate? Yes, because if it's secant tangent, it integrates to secant, right? But sine cubed times cosine, does that integrate into anything you know? No, it does not. Which means we chose poorly for u, but that's okay, right? Because that's going to happen sometimes. I wanted you to get stuck on this. Like when you get here and you're like, I can't do anything else, I probably used the wrong u, okay? On the one before where we had secant squared, we left it as secant squared because we knew that that integrated into tangent, but sine cubed, we don't know what that integrates into, just off the top of our head. So it's fine that this is here. We're just going to kind of mark this out. We need reminders of what not to do also, or when things didn't work. So instead, let's rewrite this original, ignore my 1/5 and my 5 also. I'm going to rewrite this. Do you remember when we were taking derivatives of trig functions and they were squared or cubed, that sometimes we rewrote them where it made a little bit more sense, like this? Like sine cubed of 5x is the same as sine of 5x cubed, right? And then times cosine of 5x dx. Okay? So yes, 5x is an inside function. That was a very good choice to make, right? But we got to a place where like, oh, maybe I need to make a different choice. So now look, I have this inside function. If I take the derivative or integrate this, am I going to get something related to cosine? Like those make more sense together, right? So what I'm going to choose is this for my inside function. My u is actually going to be the sine of 5x. Does that make sense? And I really, really think, I know not everybody's going to need to. I need to every time. Rewrite my cubes and my squareds and my whatever, my trig functions like this so I can see it as an inside function. That is hugely helpful. So then when I take the derivative, du, all right, well, so the derivative of sine is cosine, but I have to use what kind of rule here? Chain rule, which means I also take the derivative of the inside, which is 5. So this actually gives me 5 cosine of 5x dx. No, because in this case, very good question, I'm taking the derivative. I'm not integrating. So when I take the derivative of sine is cosine. It's when I integrate sine, it gives me the negative cosine. So you also have to make sure you're saying, which way am I going? Forwards or backwards here, right? Because it looks very similar when it's trig stuff. Okay, so now I have that du is 5 cosine of 5x dx. So here's this, but I need to multiply it by 5 on the inside, which means I need a 1/5 on the outside. And again, if you need to rewrite that step, that's totally fine. But now I can do, this is equal to 1/5 times the integral, instead of sine x, or sine of 5x, that is my u cubed, and then all of this is just du, like so. Take a minute, make sure that all you understand where everything came from. Ask me a question. Lorenzo? No, we got it. Everybody with me? All right, so now I'm going to actually integrate. I still have my 1/5. I'm going to add to the exponent. Go ahead. Yes, because when I got, this is u, right? And that's what we decided on u. When I took the derivative, du equals 5 cosine of 5x dx. So this whole thing here, all of this, is what becomes du. Well, we have to do the 1/5 so that it evens out, because we had to multiply the 5 in there to make it happen, to make it look like that, and we can't change the value of it. But since we have that rule that we can factor out a constant, since I'm multiplying by whatever happens on the inside, since I'm multiplying by that 1/5, it's going to take care of it in the end. It doesn't count. Yeah, technically, yeah, I wrote that. I can cancel them back out, but then I don't have my 5 here, so I can't replace that, right? It's like getting a common denominator and then reducing your fraction. You're just going in circles, right? It's a good question, though. We good? Okay. So when I integrate this, this becomes u to the 4th. Since it's a whole number, I'm going to just put over 4, then plus c. My integral symbol and my du go away. When they go away, I better have a plus c. So yes, it replaces it. Technically, not mathematically, but I know what you meant. All right, so now I'm going to take this 1/5 times 1/4, basically. That gives me 1/20. And then u to the 4th. So u is sine of, so this is going to be sine to the 4th of 5x plus c. Now, if you wrote it more like this, that would be a safe stop, but you need to understand that it's the same thing as that, because I would bet pretty good money this form would not be a multiple choice answer. Okay. But I do think you need to rewrite it that way. Absolutely. 100%. I do it every time. What questions we got? So I will tell you, this one's an advanced problem. Okay? I threw you an advanced one right at the beginning. If you can wrap your mind around it, that's great. This next one's very similar. See if you can get this next one done. Then we'll move on to some that are a little easier. I think the general rule for rewriting these, the good one, is like if you have secant squared, I would leave it as secant squared because it's going to give you tangent. Any of the other ones are secant and cosecant. Any of the other ones that are squared or to any exponent, I would rewrite it. Why is it negative? Because the derivative of cosine is negative sine. Right. So not only do we have to have another 2 in here, we also have to have that negative. So if I have a negative 2 on the inside, that doesn't look like a negative on the outside. I need a negative 1/2 on the outside. Make sense? All right, so then I underlined, so instead of rewriting it, which again is fine, I just underlined everything that made the du for me. So make sure I have all that. So I got negative 1/2 times the integral of, so this is my, oh, I just underlined that too. That is my u, so it's going to be u to the 4th, and then du. Everything else is my du. What did I forget? Oh, I sure did, thank you. dx. I even said that earlier. Be very careful with your notation. Okay, everybody good with me here? Then it's like a super simple little problem, right? Negative 1/2 times u to the 5th divided by 5 plus c. So that's going to become negative 1/10, and then my u is cosine to the 5th of x squared plus c. Okay? What do you think? Yep, over 10. Are y'all all doing that? Should I do it that way? Does that make more sense to you? No? That's fine. I mean, I'll do it either way. I just kind of, but it is, you do need to know, if you're writing it this way every time, you need to know it's the same as over 10, because on those multiple choice questions, it could get you, okay? So, yeah, we're going to stop here for today. If you want to try a couple of others along the way, feel free to do that. We'll talk some more about it tomorrow. Maybe try the first couple on the homework instead of jumping to some of the other examples. It's up to you.